here in the U.S., now we're seeing all of our building codes demanding an envelope, a tightened envelope, right? Mm-hmm. We're seeing the cost of energy starting to really get excessive. We're seeing, occupant health being somewhat problematic. We're in a lot of families, right? So the importance of building a good envelope and creating that safe airspace is critical anymore. And the tighter the envelope, the more critical it is that we manage the airspace, which is what we do with OASYS. We're essentially just really managing the airspace 24/7.
Hey, everybody. Welcome back to the Your Project Shepherd podcast. We've had a bit of a break for a while. We had a few changes around here, but we are back. And I've got a new podcast producer sitting behind the console back there. I've got Frances Ramos. I'm really happy to have Frances with us. Daniela was with us for the last couple of years, and she did a great job of getting this podcast kind of off on the right foot and in a good direction. But she has moved on to bigger and better things, and so I am super happy to have Frances on board. He's been killing it already doing marketing stuff for Crafted and Shepherd, and really happy to have him sitting behind the console back here on the podcast. So Frances, thanks for being with us, and we'll do something else in the future where we kind of meet him a little bit more. So I'm here today again with my friend Ken Nelson from Panasonic. This is Ken's second time on the podcast. Ken, you and I did a podcast episode about a year or so ago, and we talked mostly about Swidget at that time, you and Jim.
Right.
So you're now joining a small but exclusive list of repeat guests.
I'm going to be the lucky 5 timer here pretty soon, right?
I hope so.
Yeah, that'd be cool.
And you might catch up to Toner one day. No, you probably not. You have to do like 20 to catch up to Toner.
He's closer though, so it's...
So anyway, welcome back.
Thank you.
Happy to have you. I've been fortunate to get to hang out with you a lot over the last couple of years at Panasonic stuff, at iBiz, at EBA, all kinds of stuff. We get to see each other. We play pickleball together now. Ken and I are pickleball buddies. He kills me every time.
Well, I don't know about that, but...
So we've been working on a project. Crafted has been working on a project with Panasonic now for the last few years, and it's been top secret up until now. We couldn't talk about it, and so now that that project has wrapped up, we can finally have a conversation about it. In fact, Panasonic is doing a opening event tomorrow at the house. Of course, by the time this airs, it'll be a week or so out. But so Crafted has been building a concept house for Panasonic for the last couple of years for some new things that they've been doing, and that's what we're here to talk about. And that new thing is OASYS.
OASYS, our outdoor air system, is how I've been kind of referring to it. And we have to get a better name than Concept House. I keep wanting to come up with something more clever, but I haven't got there yet. But our Concept House, Curtis, you guys have done a great job with that, and we're excited to have it. But the goal of the Concept House is to capture data, right? We've set up our new OASYS HVAC system within the house, and then we want to capture data, inside data, outside data, and how the two correspond, or how they move in kind of a symphony of movement, where it's when things occur outside, what happens on the inside. Of course, we want that to be nothing to happen on the inside, right? Our goal is to have the inside of the house be this sanctuary of environmental space where the air quality is perfect, the temperature is perfect, the humidity is perfect, regardless of your Houston environment, which is all over the place, right? Hot, humid, cold, humid, windy, humid, PM 2.5 saturated. You guys have a whole plethora of environmental issues that occur outside, and we want to make this home a sanctuary for anybody who's concerned about healthy air, healthy living, and healthy breathing.
Yeah. So it's funny, in let's see, we kind of finished the house, let's say in December. Panasonic started moving some stuff in, setting up, and we were in mid-March now. But in the last 3 months since we finished it, Houston has had this crazy weather, which is we always have crazy weather, but usually it's crazy on the heat extreme. In the last 3 months, we've had everything from low 20s and 6 inches of snow, which is crazy for Houston. And it's been as high as 90 during that same time period.
Right.
So, just in 3 months, we've had just this wide range of environmental conditions. But, as we go through, the next 12 months through the first year of the house being in place and completed and occupied, I'm really excited to kind of see what that data shows.
Well, I'll tell you. So, and this was such a boon for us, right? I mean, holy cow, we had a cold snow episode, so to speak, right? So, which is my northern climate. I'm from Washington State. We get cold, wet, humid, and we build our houses accordingly. Here in Houston, in your central, southeast climates, you have hot, humid climates, and you build your houses appropriate for that climate zone. But in our case, being data collectors, we got to see all three scenarios that we were looking for. One was the cold climate, where the temperatures dropped down into the mid-20s. So we captured data looking at what inversion layers are doing here in Houston, and dry humidity with cold temperatures and how that affected the house. And we also saw the extreme with high temperatures, high humidity, and then we saw the sweet spot that we're trying to manage. And this is the most difficult HVAC challenge in all of the southern climate zones. And that is, we saw shoulder style temperatures, meaning that it was 73 degrees outside with 87% humidity, 73 degrees inside, but we wanted to keep the inside at 50. In this case, it was 57% humidity. And then how we can affect change with each of those if we wanted to. But the data that we're collecting is really showing some spectacular results based on the OASYS system.
Yeah, it's crazy to walk in there and see all the sensors and data loggers. Like every wall in the house has got like 6 sensors on it, and they're measuring temperature, humidity, indoor air quality at all these different points on every wall of the house.
Yeah, and I want to apologize for that right out of the gate, because I know as a custom builder, and I've seen images of some of your past work, and you build some beautiful houses. And then we came in and just killed it with every room has at least 3 monitors of some sort.
Yeah.
Some of them have 9 monitors, right? So, it has become a test house, and I apologize to you for that. But I promise you, we still appreciate how beautiful that house is.
Well, it's funny because when they first started doing that, I was kind of like, oh, I don't want to see all this stuff on the walls. But when I saw the dashboard that was the result of that and the data that was being logged, I was blown away. I was like, wow, this is really cool.
And important, right? How important is that to your home buyer to be able to look at a dashboard and say, I can tell you exactly how your house is going to respond at this temperature, this humidity. I can tell you how it's going to respond at this temperature, that humidity, and what happens when the fog rolls in and it brings all of these particulates from the coast petroleum facilities into our area, and all of a sudden, the kids are having allergic reactions, or grandma's having allergic reactions. I can tell you why, but I can tell you where it's not happening, and I can show you that on this dashboard.
Yeah. So let's kind of back up and talk about kind of the why for all this, right? So, and I'm not sure if you know this, because you're just the lowly sales and building science guy. You're not the upper top management, right? But why did Panasonic decide to come up with this OASYS concept? Like, what problem were they trying to solve, or what does traditional HVAC models get wrong? So
there's a number of things going on in the industry, right? So and Panasonic is a global organization, and to be clear, we've done this OASYS style heating and air conditioning system for 20 plus years
in Japan,
and in different parts of Asia. So, and all of those started out with an enhanced building envelope, right? They wanted to start building a better envelope. They knew they have humidity and moisture problems in those climates. And they had to figure out a way to make it more affordable for their occupants and home buyers as well. So this process has been around for some time. Here in the U.S., now we're seeing all of our building codes demanding an envelope, a tightened envelope, right? Mm-hmm. We're seeing the cost of energy starting to really get excessive. We're seeing, occupant health being somewhat problematic. We're in a lot of families, right? I mean, and one of my favorite statements and I tell this to builders all the time, when you have a customer, you just ask, how many people in your family have breathing issues, right? Whether it's asthma, allergies, or whatever. And it used to be like 1 in 4, but now it's 1 in 3 will say, oh, in my immediate family, I have, allergies or asthmas, but in my extended, which is grandparents and whatnot, there's always people in that group that have potential triggers. So the importance of building a good envelope and creating that safe airspace is critical anymore. And the tighter the envelope, the more critical it is that we manage the airspace, which is what we do with OASYS. We're essentially just really managing the airspace 24/7.
I think that, as you said, like the tightness, the building envelopes have changed over the years. Thinking back like 100 years ago, the house just kind of breathed. The house was just open. There's very little insulation. The house was not built tight. A lot of air changes, right? And then from, say, maybe the 1980s through the early 2000s, it was kind of this weird in-between period where things were starting to get tight, but not tight enough.
Sure.
And in fact, on my kind of forensic consulting business, like most of the problems that we see are kind of with these 1980s to early 2000s houses, kind of that in-between period. And now the houses are being built really tight, and that requires a whole change in mentality on how we're ventilating our homes, right. Because the house is not just going to have all these air changes on its own anymore. We have to mechanically create those air changes with these tight building envelopes, and so one of the things that that we've done on the OASYS home is we have mechanical ventilation through our ERV. So we're measuring the ventilation. It's being calculated. We're getting it right. But we're not just dumping in a bunch of fresh air from the outside, right? The ERV is helping us manage the ventilation.
Right. So we want to stay away from random air.
Yeah.
That's, and historically, right, in the way back, that's what it was. It was random air. So you would have
whatever's outside's inside.
Well, but you didn't always know where it come from. Remember we have air moves from high pressure to low. So as I heat up the inside, I'm creating this high pressure system. So it's going to migrate out. So the air that comes in most likely will be from a lower spot closer to the ground source. Mm-hmm. Typically under the house or at or around those connections, right, between the foundation and the ground source. So everything that was in your dirt or whatever would migrate back into the house. As the heat warmed it up, it would create that stack effect or chimney effect and drive it out the top. So if you were in a climate zone where you had potential for radon, you would get radon in. If you're in a climate zone where you have potential for pollen in your yard or from falling leaves or who knows what, that's all going to migrate in from that path. Here in your climate zone, in this hot, humid climate zone, we air condition the house. So now I have a hot, high pressure outside and a cooling, low pressure inside. So that air is going to migrate from the top part of the house into the house. So everything that's aerosolized. So if you have petroleum products or you have your petroleum systems out on the coastline and that moves in with that onshore flow, all of those are going to come over towards your house and now it'll be drawn into the house. But with a tight envelope, we're going to prevent that. And with managed ventilation, we're not going to allow that depressurization to occur. So we do this with that ERV. Now I can pressurize or depressurize, but you're right. We don't have the random air. So any air that comes in is being filtered. As it passes through the ERV, it's also being tempered and either humidified or dehumidified, depending on where the target is, right? So So the ERVs are really kind of one of the big magic items in that process, along with the air handler or air conditioning space that we're managing in the supply fans.
Yeah. So it's really being intentional about what we're doing instead of just leaving it to chance, right? And so I think that's one of the ways that, going back to, what do traditional HVAC systems kind of get wrong, or like the way we've been doing things, how is that getting it wrong? We're not managing our ventilation. We're just running the AC. We're heating and cooling, and
right,
dumping in some fresh air, just kind of randomly and hoping it all works out. Right. So now we're intentionally designing the whole system to not only measure the fresh air that's coming in, but also we're designing the system to where it's consistent. You don't have these big ramp up, ramp down periods of heating and cooling. So one of the great things about OASYS that I've observed over the last few months is that the temperature is very constant in the house. You're not going to walk in and it's going to be 78 and then the system's got to blast for 5 minutes and get it back down to 70, and it's going to hold it there and it's going to ramp back up. The system is very consistent with its temperature management.
Right. And that's one of the things that we're finding in the whole building science community is that heating and cooling cycle is probably the most inefficient cycle. And don't get me wrong, in our history, we had to have that because we didn't have the mechanism to give you complete and perfect air temperature and air quality throughout the house consistently. And if we did, it was expensive. It was obscenely expensive. However, now that has all changed. Our Panasonic products that we install into this system are so efficient. I mean, we're running this house, a 3,000 square foot house, for less than 1,000 watts of energy, which, it's just so remarkable that we can do that.
Okay, so what's one other thing that traditional HVAC maybe not gets wrong, but like what issues are there with a traditional HVAC model that maybe we're trying to solve with OASYS?
So one of the things that we see as being a great advantage is the repair function. Let's say something did go wrong, and with a traditional system, if your air conditioning is out, it might take 3-4 days for someone to get there. Well, I can tell you right now that you'll have a chia pet in parts of your rooms because of that moisture load is going to fire in there, hit a cold surface, adhere to that, phase change to water, and grow something, right? So with the OASYS system, repairs are simple, and they don't require the whole system to be lost or shut off or diminished. Well, I mean, diminished to some degree, right? Because we have redundancy with the air conditioning and so forth. So I would say, if you've ever experienced when your heating and cooling system has failed,
only in the summer,
and in the Northwest, it would only be in the winter, right?
Right.
You will really like this OASYS system because of that redundancy.
Yeah. So I don't want to go into like all the specifics on the design and how it's put together, but at a high level, I mean, in our concept house, we've got 2 Panasonic mini split units, which are kind of the core of the system. So I would say the two mini split units and the ERV are kind of the heart of the system, right?
Agreed.
And then beyond that, we've got some dehumidification happening with a whole house dehumidifier, and then we've got our transfer fan system. But because we have those 2 mini split units at the core of the system, if one does happen to go down, the house can function on one of those mini split systems.
Absolutely.
And that's actually kind of a testament too to the building envelope, because you think about a 3,000 square foot house that can be cooled by a single mini split system. That's pretty impressive.
Yeah, a single 2-ton system is basically 1/4, 1/5 of what you would have in a traditional 3,000 square foot house. And it will do just fine. And a lot of that is we go back to that ERV. That ERV is going to diminish that HVAC load required that's coming into the house.
Because it's preconditioning the air as it comes in, right?
Taking that humidity out so that the ductless system or the mini split system doesn't have to work as hard. I would say, you talk about the heart, the ERV and the mini splits are certainly the heart, and then the distribution fans and the supply fans, if you will, are the vascular system. If we're going to humanize this, the vascular system. And I have to tell you even though we have a dehumidifier in that space, it's not coming on. It's not running, even in the super high days. And I want to double check that data as we get more of it. But right now, we're not seeing dehumidification as from a specific device being even necessary so far. But I want to, like you, I want to see what a year's worth of data looks like.
Yeah.
But we've seen all the the swings and sags and swells.
Yeah, we'll see 110 in July with 80% humidity and see how it rolls then. But
that's a lot of water in the there's for sure.
But yeah, I mean, I think that because we're already getting some dehumidification from the mini splits and from the ERV, the whole house dehumidifier we spec'd on this project because it's Houston, because most of our homes here we do that now. But it'll be interesting to see as we gather data if that component is 100% necessary in this home.
Right.
So, and if it's not, great. That's another $1,500, $2,000 that someone could save on at least on installing a system if they can cut that out too.
Well, that's another important part of all of home building, right? Is affordability. And it doesn't matter what house, if you buy a first-time home buyer, a move-up home buyer, or a luxury house, everybody wants it for less, right? No matter what. That's just a standard thing. I want it for less. And making things affordable but livable is always the challenge, because an affordable or first-time home buyer, you may not be able to afford those higher-end comfort products. But with this system, we can give you 99% of that for the same price as a luxury house. It's pretty remarkable how this is scalable, both from a functional standpoint as well as a pricing standpoint.
Yeah, the cost of the components involved are not crazy. So that's one of the questions that I've gotten from people as I've showed them the house, talked about the house. Is what does this cost versus a traditional HVAC system? And it's now this was a prototype house, right? This is the first time that we've done in the U.S. Although, as you said, they've done a ton of them in Japan, tens of thousands of them in Japan. But here in the U.S., this is the first one. So it was our HVAC installer's first time doing this as well. So obviously he's going to charge me a little more first time, has never dealt with it. But now that he's been through it, he's like, oh yeah, that was not difficult. It's too many split units. It's running dedicated like home run duct lines for the transfer fans, and there's nothing crazy about the installation.
The installation magic is in design.
Yes.
Right. That comes before the house is even out of the dirt. It comes in that architectural design, that engineering design that you're going to receive, and almost all of the complications should be resolved right there. And when I say complications, there's no, you have to find a 4 foot by 2 foot plenum chase, type thing to move trunk lines from A to B and then have them balanced because you're reducing sizes and you've got grill register diffusers throughout that are trying to modify airflow. None of that occurs, right? We measure that with the outbound supply fan, and we just have a fan for each of those spaces, and it's predictable. And quite frankly, part of our process is that we test the fan where the air comes into the fan, and we're going to test the fan where the air comes out of the fan and make sure we have that same airflow in, the same airflow out. And now the house is going to be perfectly pressurized. It won't have more pressure in one space, less pressure in another. So now you're starved for cooling or heating in one spot and you have too much in another. You won't have stratification issues. All of that is resolved in design.
Yeah. And so on the design side, and again, I know that our project was a little bit different because it was the prototype, but I think it's going to be the same model probably moving forward. So you've got your architect. So in this case, it was KTGY. So we got our architect, we got the Panasonic team, and then we've got our building performance designer who are kind of working together on this. And so talk about how those three, well, and the builder, of course, right? So talk about how those parties, Panasonic, performance designer, architect and builder kind of all work together during design to figure this out?
Well, I think that again, I'm going to go back to saying it starts with design. As a builder, you look at a set of floor plans and it's intuitive, right? What you see is intuitive. Well, if that floor plan shows these HVAC pathways, if it shows open web trussing, you know how to manage that. That's not a big deal for you. It's more problematic for you when you have to build, like I said earlier, these large chases and create, air conditioning rooms up in the attic where you can get some sort of a transfer system occurring or a booster system occurring. We start with the design. We get engineering to look at every cubic foot of space within the house, and they're going to say how much airflow we need in each of those spaces. And then they're going to also talk about how many fans it's going to take to move that airflow into those spaces. And then for you, they're going to hand you a package that says, listen, here it is. This is going to work. And now for us, our certification for the builder comes down to, I need you to be able to look at the plan and make that plan come to fruition, right. And not, we have oftentimes the builder can shortcut the practices, but with this is a design system. Shortcutting, there's no shortcuts. We're already bringing you every shortcut known into that structure. So it's an easy build for you. You don't have to be super creative. And your feedback back to the designer also is super important to help the designer create these less complicated applications.
Yeah. So on the design side, when we've got a traditional AC system, you can kind of just stick the air handler in the furnace kind of wherever you want in the attic or in a closet, or a small closet or whatever. With OASYS, we do need a little bit larger dedicated space to house the system. So during design, that's going to be, again, the architect working with the Panasonic team to make sure that we have that space for the mini splits, the transfer fans or the supply fans. And just understanding kind of where that's going to live in the floor plan, how those ducts are going to get to where they're going. It's not rocket science, but it's just again, knowing what the loads are in each room is going to tell us how many fans we need.
Right. And
so based on that, we can look at, can we locate this in a closet? Can we locate this in an attic? Whatever, right. but that's all something that's figured out during design by the team.
Right.
Whereas normally with HVAC stuff these days, a lot of it's kind of done in the field. It's like, hey, we know we're putting in a furnace and an air handler. Let's frame it, and then we're going to figure out where the unit's going to go.
Right. The HVAC guy comes in and says, Curtis, I need a platform in this space, and it's got to be by this. And you're like,
I need you to pop a chase in the corner or whatever.
Right.
And so it's kind of
you modify these truss arms, and you're like,
Yeah. A lot of times, traditional HVAC installation is a little bit more on the fly. Right. We're just going to do it in the field. And that's worked for a long time. But, again, with the building envelopes that we have, advanced planning is more important. But with a system like OASYS, just the way it's configured, it's really important for all the parties to decide before construction ever starts, where's this going to live? How are things getting from point A to point B? So, using web trusses is for a two-story structure. You got to do it,
right?
So I think we used 20-inch web trusses. 24 is really a better way to go if you can swing 24 with your building height requirements. We had to go 20-inch, I think, on ours because we had a max building height. But a 24-inch web truss would be better.
But you knew that at design, not after the thing was set on the site, right?
Right. Yeah, but the fact that all the ducts that we used are all 6-inch ducts, made that very manageable.
Oh, yeah.
Because even though we have a lot of ducts all coming to a central home run location, they're all 6-inch. And again, during design with the architect, we knew that we had, X number of ducts running up into the attic space, X number of ducts running down into the subfloor. And we had all that laid out before we ever started. So it wasn't anything where we're on site and we get surprised and we're scratching our head like, hey, how are we going to make this work?
Right. And then, there's a phrase that I love, and I use it all the time, and I use it with ventilation, right? We always want our ventilation to be predictable and uneventful. And that's the same way you want every job, right? It's probably the best thing in the world when you can look at the plan here in the office, make your order to your supplier for a product, and then have it show up on the job site and put it together as it shows on the plan, and then everything just works. There's no modifications required.
I like predictable and uneventful. Like your air conditioning should be boring.
Right.
Honestly.
Oh, yeah. Ventilation should be invisible.
Like, you don't want to be thinking about your air conditioning. Like, if you're thinking about it, it's because you're getting too hot or you're getting too cold. Like, you shouldn't have to think about that. If your ventilation, if your air conditioning, HVAC system is functioning right, you should just walk into the house and it feels good and you're not worried about constantly tweaking it.
So, and those are there's two things that I think are really difficult for the builder to try to gain value out of, right? One is healthy indoor air quality, and the other is comfort. Because the homeowner, the home buyer, he expects both of those automatically. So how do you create value in your presentations to assure that homeowner that he's getting both of those? Because that's critical, right? I mean, that's oftentimes that's the reason somebody's coming to you, is they have a pain point from a previous living experience, whether it's an apartment or a house or whatever, that's either leaky, cold, hot, sweaty, who knows what. But there's something oftentimes driving them into that product, and now you have to make them feel good about it. And this is a great way to do that, because we can show data. I can show you how these things work. You have user experience where it is comfortable, and you know that, and you can, we need to create like a model home, I guess, to some degree, to be able to have that user experience really be expressed. But bringing value to comfort and healthy indoor air quality is critical.
Yeah. So one thing that you just touched on there, we touched on it briefly at the beginning, is air quality. So that's one of the other things that I think OASYS gives that a lot of traditional HVAC systems don't provide, is just an improved air quality, not just because the air is being filtered as it comes in, with the ERV, but also talk about air purification. Well, let's talk about all the different ways it gets filtered and cleaned, but also how the purification works as well.
So outdoor air coming in first cycles through the ERV, where it's going past a MERV 13 filter into the ERV, where it's being the ERV simply wants to bring everything to the middle. So if I have a high temperature outside, a lower temperature inside, the ERV is going to allow those temperature streams to kind of meld into one another. So it's going to reduce that hot air that's coming into the house, and it's going to reduce the cold air that's leaving the house by tempering that hot air coming in. So you recapture that heat and temperature. And then as it passes, and that's also part of the dehumidification process, because one of the ways that we move heat temperature is through moisture vapor, right? That water vapor carries more temperature than air. So it moves from hot to cold, from wet to dry, and high pressure to low. So heat is high pressure. More moisture load moves into that cooler airstream. It's drawn off, pushed out, bringing in the heat, and now it's pushed out of the house. That air is put in front of the air conditioning room, or the air handler room, where it's drawn in, where we have our two mini split heads in there. And the Panasonic mini split heads are unique in that they use what they call the NanoX technology, which the NanoX technology is essentially a positively charged hydrogen molecule. It positively charges hydrogen molecules, if you will. And as that air passes through that head assembly, it's being charged, and it uses what they call a hydroxyl radical to charge that molecule, that hydrogen molecule. And what it does is it hits that molecule and it gives a little static charge. That molecule lives in that space for 1, maybe 2 seconds. So it relies on that large airflow. So we're, on a mini split head will move between 300 and about 750 CFM of air per minute. That's cubic feet per minute. So we have 2 of those moving that air. So there's a lot of air that's being I shouldn't say purified, but it's being treated as it passes through to be redistributed out to the house, where it's now diffused into that space and brought back in, and the process starts over. In addition to that, we have some of our whisper air repairs, same process in the I don't know what we call that, but it's like just off the kitchen area, where you have a lot of VOCs that get outgassed from cooking and cleaning and whatnot.
It's also a big gathering area for
It's a big
for
gathering.
people.
Exactly. So, and one of the metrics we're going to be able to look at is how is CO2 handled, right? When you get a bunch of people in there, and we have an occupant, of course, as you know, living in there and his family, and I keep encouraging them, hey, you guys need to whoop it up on the weekends so that we get
Have
these
some people over.
yeah, whoop it up, party. We want to see these spikes and then how fast they get dropped off.
Yeah.
Right. I want to see, and one of the challenges with ERVs and using indoor air quality monitors is because you have constant diffusion, constant turn of the air, your monitors get pretty boring to look at. So it takes a lot. And unlike we're a house with no airflow, where it takes very little to create a IAQ trigger alert. Once the air starts moving, and we're moving the air, I think 3.5 times per hour, every 17 minutes, every cubic foot of air in that house is being spun through the air handler room, and where the Nano X is taking place, it's being spun, it's being diffused with ERV air, fresh air from the outside every 17 minutes. So it's going to be difficult to get spikes.
Yeah.
We've even looked at it, the initial data. We had one spike in the initial data, and at that point we had 20 people in the house, and the spike only occurred in the CO2 and dropped off within 10 minutes of everybody being gone.
Wow.
So this is the kind of data that we look for, and we're excited to see.
Yeah. Again, we want boring when it comes to the data too, right?
Exactly.
We don't want
just like people probably fell asleep as I explained all that, but I'm so sorry. It's just. But to your point, our comfort level and our health levels, we shouldn't have to fight for those every day, right? We want that just to be our space.
Yeah. So I mean that's really kind of the whole point of OASYS and is just this general well-being and comfort, right?
Yes.
And so on this concept home, we've got the OASYS HVAC system. We've also got the Whisper Air Repair, which technically isn't part of OASYS, but it's another great product that we used in the house that plays well with that concept. We've got our solar. We've got our Evervolt solar system in the house, which is also really cool. Kind of on one of the dashboards that got created. We were able to see what the house's energy usage and kind of what's being produced and stored versus what's being bought from the grid, and so that's really cool. So yeah, the house is really kind of. It's just a big concept of efficiency and healthy living.
Right. Yeah. The fun part about the house is ultimately when you do describe it from a real higher level, it's not just a net zero. It's a net positive most of the time. I mean, our HER score was -3, for heaven's sakes.
Yeah.
So we couldn't be more excited about the ability to create such a space for occupancy, right? So, literally, we can create a space for, and part of that -3 HER score, and part of that not just net zero, but net positive, is the way that we reduce the expense or the energy consumption of the house by making it a super tight envelope, by having super efficient products that heating and cooling, by not allowing it to spike temperatures because we're running continuously rather than trying to shove hundreds or thousands of CFM of air into the house, heated, which air, by the way, is the worst medium to carry heating and cooling. But we want to keep that house at that right level all the time, not just wherever the setback occurs.
Yeah, I thought of kind of a car analogy. You're if you watch your miles per gallon indicator on your dashboard on your car, when is it sucking the most gas? When does your fuel efficiency drop down to 5 miles per gallon instead of 20 or 30?
Right.
when you hit the accelerator and it has to speed up and work the hardest.
You know what? That's one of the features that has changed behavior, right? Is the dashboard. And I know that my wife has a Prius, and that Prius shows just as you described, right? It shows you when you're using more energy than creating it, and she works really hard to keep that energy at an appropriate value so that it's not, drawing off excess energy or excess fuel. The same thing with the house. If I can keep this house right in my target zone, if you will, it's not going to take excessive amounts of energy to heat and cool it to bring it back to where I want it to be.
Yeah. Kind of the last thing on that topic of all the different products that are in there. So on the solar side, we also have the Evervolt batteries. So we also have kind of it sounds kind of corny. We also have an OASYS if the power goes out, right? So we have that backup capability, and we have our critical loads that are tied to our Evervolt battery and smart box, so that when the power goes off, which we have a lot of power outages here in Houston, unfortunately, especially during hurricane season. So when that power goes off, our OASYS air conditioning system is going to keep operating. Our refrigerator and freezer is going to keep operating, some basic lighting circuits, right?
Right.
So we're not trying to run the entire house with that backup, because it's kind of a waste of stored energy. You don't need every single light switch and phone charger in the house to run when your power's out, but you want to maintain basic levels of comfort and safety, right?
Right.
And so by managing those critical loads, we've also created this, again, we've created this OASYS during a storm.
So, and not just OASYS, but sanctuary. I keep coming back to that term. I love that term, because if you're compromised and you need, whether it's oxygen or you need some sort of health care in your house that requires power, and all of a sudden the power goes out, all of a sudden this has a whole different feel about it, right?
Yeah.
Or if you're sensitive to high temperature or low temperature and the power goes out, all of a sudden, this is a bigger problem.
Yeah.
So, as you said, we can basically take that battery package and give you power, 6 to 8 hours, depending on the load, of course, by just doing your critical load sources. I know that one of my issues, and I'm trying to do this at my house, right? I want to add solar, battery, but also my EV chargers, right? Because one of the things about stored batteries, stored energy, is it has no value just being stored. It has value when it's used. It's drawn and recycled, right? Because with solar, I'm recycling that energy. So my big goal is I want to get an EV car, and I'll have my EV charger, my battery, and I'll just charge my car off my battery, because I want to constantly use my charged energy rather than having it just sit there like a can of gas and at my house currently I have a generator. It's a propane generator. I keep, 10 gallons of propane and my generator at the ready, but it's never used. So to me, it has more value if I'm using it, and then it's ready when I need it, because it's not constrained to my utility that may or may not be able to provide service like I need it to.
Yep. So kind of the last thing that I wanted to touch on in our episode here is talking about implementation of OASYS. So, I'm sure that you have too. I've had a lot of builders here in Houston and some builders from around the country who reached out and said, okay, if I want to implement OASYS, if I want to try it, what do I have to do differently from what I'm currently doing? So, what do builders have to change in order to try it?
And that's actually a great question, because, I would state it's going to start at the design, right? Once you create this new design process, and we're going to help you with that. And to be honest, there's a certification and a certification fee for the builder, but then we also are going to certify, and I don't know what that fee is for the design. We'll probably use our internal design so that that fee is less onerous. I mean, I don't want to kill everybody in fees, but
sure.
The reality is the design is going to be where it all starts. You'll be a certified builder, which just tells us that you're going to adhere to the design that you see. The engineering is going to come probably from us at this point, because we do know the engineering on this. Hot, humid climates, we have worked with that for years and years and years. We can tell you, if you make a mistake, we can tell you the result because it's been done before. So we're trying to avoid all those mistakes by, again, going back to that design. But from the builder perspective, we need you to adhere to that design.
Yep. And beyond that, I mean, again, modern building codes are requiring tighter and tighter envelopes, but not all states, cities are kind of on the newest version of the code. People are sometimes way back on adoption of codes.
Sure.
And some states and cities don't even mandate a certain code, but so building a tight building envelope is essential for the success of the system. We can't have a 5 air change an hour envelope for this thing to really perform at its best. So it's specifying the right products. It's making sure those are installed in the right manner, making sure we're doing testing to ensure that our envelope is tight before we move forward, right? Right.
And we're also going to test the system to make sure that everything that we've required and we said this device would do is doing what it said it's going to do. So there is from the builder perspective, there is design, there's testing, there's installation, more testing.
Yeah.
But at the end of the day, it's a great product, and the product is so, it just works, right? It just works, and it doesn't require a lot of hand-holding to your occupants to teach them how it works. Probably requires more discussion with your occupants to just allow it to work.
Yeah.
Right?
Don't sit there and constantly mess with it.
Yeah. Don't overthink this process. Set it and forget it. And, call us if you feel like it's not there. But yeah, set it and forget it. It'll work.
Yeah. But again, from a builder's perspective, I think hopefully builders are already trying to build at that level. I would just go ahead and say, in my opinion, this is not a Panasonic position. In my opinion, if you're a low performance builder, or if you don't care about a tight envelope, if you don't care about building science, this is not the product for you to try on a house, right? Like you need to have some dedication to, I'm going to build a good product, I'm going to build a good envelope, and I want to use good systems.
Right. So honestly, that builder's probably not going to call us.
Right.
That builder's not going to call us. That barely legal builder is probably not going to be our customer. And he's, and don't get me wrong, he satisfies a market niche, right? But it's not where we're going to play. We're looking at that market niche where everyone wants good quality, healthy air. They want a safe space to live in. They want a good envelope because they want to be comfortable and not have, the transaction. It's funny, when you buy a house, you have certain transaction points, right? We have a transaction point of when you purchase the house from that builder. And then you have the rest of your life with a transaction point every month where utility bills, comfort level bills, do I put in space heaters because this bathroom's cold or whatever. All of these continue to follow along for the rest of the life of the house. So really you can do nothing with the house and build a very poor house or a barely legal house. I don't want to say a poor house. It's not a poor house. It's barely legal house, and reduce that transaction point. Or you can add a couple of points to that initial transaction, but diminish this all along for the next 25 to 50 years. And that's a big deal, right? It's a huge deal, honestly, in the sustainability of this product going forward.
Yeah, and with kind of that low upfront transaction cost, you're also probably not getting the health and wellness aspect.
Oh, absolutely
at that
not.
point either. So, I said this already. To me, this is really more of a way of approaching kind of overall wellness, health, air quality, and that's what I like about the concept,
right.
The products. It's all about healthier living.
Right. That's exactly right.
So, well, I think that's a great point, great place to wrap it up. So,
thank you.
I appreciate you joining me today. It's always great to see you.
Yeah.
And I'm not sure if we can squeeze in some pickleball on this trip, but I know you're busy with the opening event and got all the Panasonic folks here in town this week.
Right. I've got the whole family.
But I know that you'll be coming here a lot over the next year, probably, as we as we get more into starting to sell the system and demoing it and testing and all that stuff, I'm sure that I'll be seeing you around a lot.
Yeah. I look forward to sharing some data dates, if you will, where we put together all of the data, and we'll come in and just discuss the data and look at how can we affect change with data without, moving walls or ceilings or who knows what. But I mean, let the data help with the design, and I'll be reaching out to you for that.
Yeah, hopefully like a year from now we can do another one of these and just say, hey, here's what we learned over the last year.
In the background, we're gonna put a whole pile of spreadsheets and graphs and charts, and
we can get Francis to pop a bunch of graphics on the screen and showing all this stuff. So, well, thanks again, Ken. Always great to see you and hang out with you.
Thanks, Curtis. I look forward to doing another day.
Yeah, and thanks to all of you for listening to the Aura Project Shepherd podcast. Hope to see you again soon. Bye-bye.